Welcome to CFD for Industry. I'm Cade Beck, and I'm your host. In this podcast, we'll pull back the curtain on what it takes to do successful CFD for industry. We'll talk with industry experts at the leading edge of technology who have diverse business, consulting, and research and development experience. So join me as we learn together about what it takes to do CFD for industry. Prior to leading SimScale's rotating machinery and fluid flow control markets, Kanchan Garg was the CTO at Sukra Helitek, a helicopter aerospace CFD company, where she built and ran the firm's Asia business. Her responsibilities included hiring, providing training workshops for industry, consulting, as well as marketing and fundraising. Kanchan has extensive experience as a CFD software developer, but she's also familiar with what it takes to lead teams and provide top-tier consulting services. In today's episode, we'll learn what experiences prepared Kanchan to succeed doing CFD for industry. Thank you, Kanchan, for joining the show today. How are you?
I'm doing very good, and thank you, Kate, for inviting me. It is an absolute honor, and I'm really looking forward to having a very lively discussion with you over the next few minutes.
Yes, no, this will be great. Before we get into that lively discussion, could you give us a little bit of your background? Just what was your first experience with CFD and what are you doing now? So kind of a brief overview, I guess, of how you started and where you're at now.
So I'm an aerospace engineer by training. I did my undergraduate studies in aerospace engineering in India at the Indian Institute of Technology, Kanpur, and then did my master's at Iowa State University with a focus on computational fluid dynamics. And my first job out of academia or out of college was with the company that my major professor founded. It was called Sukra Helitek. And I started as a developer there. It was a niche software development firm specifically for helicopter aerodynamics. So, over the next 10 years, I held different positions. It was a small company, mainly bootstrap, but it was a wonderful experience to go really deep into this one particular industry, have the opportunity to meet a lot of established professors and director level people across the industry. From there, I then joined SimScale as a product manager, where I am at right now. I'm the product manager for rotating machinery and flow control applications. So SimScale, as some of you might know, is the world's first cloud native simulation software. And here I brought my expertise and experience in rotating machinery CFD to drive the vision and the growth for a SaaS product, which democratizes simulation, which makes it accessible to engineers, designers all across the organization and all across the product's life cycle. So it's two different roles that I've held, from a small company to a startup, but still quite a larger startup. And in terms of where I started about CFD, it goes back to my sophomore year. It started with a project. So I had nothing to do, in my summer holidays, and I saw all my friends, like, somebody's doing a course on CATIA, somebody else is, I don't know, building balsa wood air gliders. So I was like, yeah, what should I do? So I approached this Professor T.K. Gupta, and he's retired now. I said, do you have a project for me? So he was the head of the high performance computing lab there, and he said, yeah, sure, come on in, spend a few hours a day. And I mainly helped out the grad students there in that lab, right? Like in that 2 months, all I did was generate plots, not knowing exactly, what I was generating plots about. I could identify something, okay, coefficient of lift, drag, airfoils, that rang a bell, but I didn't understand. Then in my junior year is when I took my first CFD course. And following in that summer, I did an internship at Iowa State University, where I wrote my first code as such, or at least part of a code in Fortran, which was to do with developing some additional source terms for a flux corrected method in finite volume. And I applied that code to study the problem of a lid driven cavity, right? Like how does the flow change? And I read up on, why do we need to simulate a lid driven cavity, right? What relevance does that have to real life? So that's where the connect happened. In that junior year summer is where the connect happened from the textbook coursework and the theory that I was studying, fluid mechanics, aerodynamics one, Navier-Stokes equations. We've been studying it for 3 years now, but that connect to an actual real life problem and how these equations transfer themselves to solving a physical problem, that happened. And from there, then I was hooked.
I'm so glad you touched on that. I've had this analogy come to my mind recently that you just used it in different words, right? Like you build up this knowledge and it's like the potential energy. And then when you're
Yep.
able to take that and convert it or connect it to something in industry, it's like converting that potential
Yeah.
energy to kinetic energy. And then depending on how you apply that for industry, the formal definition of work is a force times a distance. Sometimes
Yes.
we do a lot of work, but we're not
Yes.
actually moving something a distance. So I love how you talked about connecting it and converting that to kinetic energy, right?
Yeah.
It's really where the learning happens. That's awesome. And thank you for introducing yourself and explaining where you're at. So let's dive into this a little bit more. Where did it go from here, right? So that's where you connected it for the first time. Were
Yeah.
there formal courses on CFD that then you ended up taking your senior year, and what happened after that?
I had already taken an introductory level course in CFD.
Okay.
But to be very honest, before that internship in my junior year, it was all a bit blurry, right? I
Mm-hmm.
didn't understand what we were doing. But then, yes, I did take some advanced level courses and went on to do like even grad courses in transition and turbulence. And I made up my mind that yes, this is the field I want to study. And I felt that my undergraduate studies were not sufficient for me to really be proficient in this field. Because obviously, in undergraduate, I think the focus of most engineering colleges everywhere in the world is to give an overview.
Mm-hmm.
You're an aerospace engineer, for example, or you're a mechanical or a civil engineer based on where you're coming from.
Mm-hmm.
And the idea there is to give you an overview of all the disciplines. But if you really want to specialize in CFD, then you have to go for higher studies, either a master or a PhD. So that's when I went back to Iowa State University. And there, then I took further, more advanced coursework. And one thing that I really liked there was the first level grad course was actually not about CFD per se. It was about numerical modeling, like numerical methods.
Mm-hmm.
What do you mean by discretization, right? What do you mean by second order PDE, for example?
Yeah.
And I wish that had happened in my undergrad as well.
Mm-hmm.
Like I had formed the mathematical basis, or I had strengthened the mathematical basis before going on to the actual physical concepts. But anyway, it was a good journey as such. So yes, coursework and research work. And the good thing about the research work that I was part of was it was funded by the US Army at that time. So it was one of a very pressing problems that researchers were trying to solve
Hmm.
in rotorcraft. So
Yeah.
that again resonated, right? Like because then that again gives you as a student, it gives me a purpose. It allows me to see that the code that I'm writing or all the literature review that I'm doing is actually going towards solving an industrial problem. So I really think that project work, and not just project work from the point of view or research work from the point of view of writing papers, but actually taking an industrial problem and trying to apply the research to it, that's important.
Yeah, that's excellent. And it really does change. I can relate to that experience a lot with my research, that it was solving something that, yeah, that people care about and that you're contributing
Yeah,
to the field, right? It really does go a
exactly.
long way with some of those long
Yeah,
articles and really trying to
yeah,
figure out what they're saying and
yeah,
what
yeah,
what the best way to move forward is, huh? It's interesting. I just want to touch on another thing as you're talking about you're exposed to these principles and these concepts in undergrad and how grasping them. So I've been reading a book recently. I've got 4 young kids, and so I'm interested
yeah,
in just the science of learning, right? And one of the things that I'm seeing is a very common thread in any learning setting, but take reading, for example, right? A child learns to read and they're so focused on the phonics of sounding out the word
yes,
that their
yes,
comprehension is just zero. And that's okay because they're spending all their effort. And I feel like there's an analogous principle in what you described, and that's been my experience as well. First time you're exposed to a technical concept, you're just trying to
yes.
grasp what are these terms, or maybe it's in some tensor
Why? Yeah,
notation you've never seen before,
exactly,
and you don't
exactly.
really see it till the second or third or fourth time around. And so that comprehension, and it's very similar. I think it's just a normal pattern of the brain, right? We have to put it together to know what we're looking at, and then the understanding
Yeah.
comes later.
Exactly. Yeah,
So yeah, I
yeah.
feel like that's very normal in how things go. But thank you for touching on that again. So let's talk a little bit more specifically what details you can share. I looked at your thesis and it's very interesting. So if you can describe a little bit more about that and
Yeah.
maybe some technical turning points for you of when you felt like, okay, I'm really starting to get a handle on this, or I'm really feeling like I'm learning how to think like a CFD engineer, right? Maybe is that something that you felt like happened, and maybe you can describe an experience or two?
So my thesis was on momentum source modeling. So which is basically what it does is that it replaces rotating blades, because whenever you have a moving object, you need to remesh it in order to include its influence. So obviously that is the most highest fidelity way of doing things. And there are several methodologies that cover that, whether it is a sliding mesh method, overset grid, but all of those are computationally expensive, right? And it's
Hmm.
also technology that is probably not available or not possible to get some quick early stage design solution. So what our research team was working on was this momentum source model, which basically replaces the physical blades with virtual sources of momentum that rotate in the flow. And my contribution to that chain of work that had been going on for many years was to create an unsteady source term which basically mimics the exact location, the exact RPM, and blade deflections as well within the flow field. So obviously this is slightly mid fidelity in terms of accounting for all the effect that the rotor has on the flow field, but it does pretty well in terms of getting rotor performance, and it's a very popularly used technique, especially in external aerodynamics. And in that, I think the turning point for me was when we took this particular momentum source model and coupled it with a dispersed phase model to study the problem of helicopter brownout. Then again, it's the same thing where you are taking pieces of research that different people have worked on, different masters and PhD students have worked on, and putting it together to solve a problem that is of huge importance. Basically, like dust cloud formations when helicopters are trying to land or take off. So that's an interesting area, right? So that was sort of a turning point for me.
What do you feel like you came away with from your master's with? Like that ability to just identify what pieces were needed to solve the problem, right? Maybe that's what you just described is being able to look at any problem and say, okay, what resources do I have and what's the best way to take this to the next level, right? So
Yeah. Yeah. Well, I would qualify that by saying not every problem, but
sure,
yeah, definitely in the field of rotorcraft and
sure.
external aerodynamics, yes, it gave me the confidence to, even on a general sense, like have a conversation about it, because it's something when you've spent a master thesis or even PhD, even more so, you have looked at a lot of literature, right? You have looked at
Hmm.
what is the state of the art, what are other research groups doing, what are the pressing problems in the industry. So that gives you quite a lot of in-depth knowledge about that particular field. So I came out, yes, being more confident that I can, first of all, write a CFD code, start to finish,
Hmm.
right? So, and I do understand a lot of concepts in CFD. Even there, I wouldn't say I know everything because my work was in finite volume, RANS-based methods. But at least I can, understand what other CFD work is going on in this field. So yeah, it does give you a confidence of being able to tackle, more wider set of problems.
Yeah. Yeah, one of the ways I've thought of it is in undergrad, hopefully you learned how to think like an engineer. You might not remember everything, right? But
Exactly.
you learned how to think. And
Yeah,
then
yeah.
as a researcher, hopefully you learned how to use your way of thinking to create something new.
Yeah.
And yeah, qualifying it
To
within your space and what you know and what you're
to
familiar with.
dive deeper, basically.
Hmm. Yeah, yep. So let's touch on this concept of commercial codes versus writing your own codes, right? It's
Yeah,
almost
yeah,
inevitable
yeah.
that well, yeah, and maybe I'll preface this with, and we've talked about this briefly before the show, but well, I'll let you explain it first. Just go ahead. When did you use your first commercial code, and how much code did you write before you used your first commercial code?
I didn't touch a commercial code. I think I might have used Katia, but no CFD code in my entire undergrad or grad studies because The coursework was structured in that way, the research was structured in that way that we were always encouraged to learn CFD by writing our own code or either understanding somebody else's code,
Mm-hmm.
running it to see, or make additions to that, or write your own modules to it. All the project work in all the assignments, even in the coursework that I did, was like stuff like solve this ODE constraint to this so and so boundary condition or so and so initial condition, or generate a C type grid, for example, for an airfoil. So at that time there was a lot of focus. There were resources available
Mm-hmm.
within the university. We had licenses of commercial tools in the computer labs, but there wasn't much incentive for us to spend time on that.
Mm-hmm.
And it's a good thing. So I would actually argue both sides of this.
Yeah.
So I think by writing my own code and actually diving deeper inside, I can now work with any commercial code, right? I know
Mm-hmm.
I can think in terms of methods
Mm-hmm.
rather than the UI that I see in front
Yeah.
of me, right? I can compare capabilities and I can understand, which would be better and what to expect from a particular simulation. Having said that, though, I wish I had some exposure or some incentive to even, spend my spare time in learning commercial software, precisely for the reason that there's only so many problems or so many sub-segments of CFD that you can learn by reading a textbook or attending a course, a lecture, or writing your own code.
Mm-hmm.
Using a commercial software, on the other hand, allows you to explore so much more. For example, my core area is external aerodynamics, right?
Mm-hmm.
I know the concepts of aeroacoustics. I may never write a code on aeroacoustics, but if I had access to a commercial code, I might run a simulation on aeroacoustics to learn more about that kind of physics. So I think it is important for academia or the curriculum nowadays to incorporate some focus on commercial software, either in terms of elective courses or extra credits, and especially with all these new technologies coming up like generative AI and additive manufacturing and all of these things. These are all very digitally connected, right?
Yeah.
Sure, there is somebody writing code behind all of this to make that possible, but in order to get an overview, I think it's also important to get hands on with the industry state of the art.
Yeah. Yeah. That's great points. And thanks for sharing your experience on that. There's definitely a broad swath of ways to approach it, right? Even professors oftentimes organize their research groups with someone who's really good at meshing, someone who's really good at the
Yeah,
post-processing and
yeah,
this. And so
yeah,
even among a research group in academia, they're not learning everything. It's simply
yeah.
impossible to learn
To learn
everything. And so
everything, exactly.
it's up to the engineer to recognize what the limits of their capabilities are in using those tools wisely, right? And
Definitely, yeah,
hopefully everyone has the intrinsic desire to do that
yeah.
before they send results on. So let's talk about your transition. So really got a good understanding. And then what did you do after Iowa State?
So after Iowa State, I joined the company that was founded by my major professor, as I said, Sukra Helitek. I joined as a CFD developer. So this was also a company focusing on this niche market of helicopters and helicopter aerodynamics, funded by government organizations. So we had a software product which we used to market as is for end users within the government and some big enterprise customers as well. And we also took on a little bit of consulting work on the side. So my first role here was just as a CFD developer, but very early on in this role, because we were a small company, like a small team, everybody did everything. So very early on, I found myself not only just writing CFD code, but also, compiling and learning about version control, learning about development, the software design and development aspect of things, and writing proposals for government grants. So juggling a lot of things. And from there, I got the opportunity. I wanted to come back to India. So I got the opportunity if I would like to start a team here in India to support the US office and also to, expand business here in India. And I took on that role. as a CTO. But honestly, looking back at myself like 12, 13 years ago, I think now, what was I thinking? I didn't know anything, right? I learned a lot after that. And the main things that I cherish from my role as CTO, as Sukra Helitek India, is this opportunity, this immense opportunity that I got to learn from really established, knowledgeable people in the industry.
Mhm.
Because I don't think as a 20 something you get an opportunity to stand up in front of a crowd at a government organization full of, different people like engineers and directors and whatnot who've been doing this for like 20, 30 years and talk about your product. So as scary as it seemed then, I'm really happy that I got that opportunity because that gave me the exposure to, hone myself, my own public speaking, presentation, and, people management skill. And I wouldn't have learned all of that by staying behind a computer. I love CFD, right?
Hmm.
And I continue to be a developer all through my years at Sukra Helitek, but what I take away from that job is this exposure that I got to speak with industry, academia, and bring all of that knowledge back, and try to develop a good product. So yeah, that's been the journey in my, transition from academia to also an academic oriented R&D kind of a company.
Hmm.
So it was 50-50. It was like R&D, but for industry.
Yeah. Yeah. What things did you do to help with that transition, right? It's a different set of skills than what you're trained for, right? And so what were
Yeah.
things that you did that helped you excel in that role?
I think I think it's mostly about, interpersonal skills that come into play here because technically speaking, yes, if we were selected for that job to we obviously, one obviously has those technical skills. But to be in a leadership role like that and to, it comes down to a lot to things like being able to present your results, for example, right? If you did a simulation, you have results, or you have some outcome from some project, being able to articulate it and present it in a certain manner that connects it to some business outcome, right? And as engineers, usually I don't think we are trained to think that way. And I think I can safely say that a lot of us, we learn this on the job,
Hmm.
right? All of us need to do this, right? All of us need to make these, you know take technical projects and take technical outcomes and present it to in a more business oriented way. So I wish that could be incorporated in our training as engineers. But yeah, this is something that you learn on the job, and I would really say that it is important to focus on self interpersonal skills, right? Like how good are you in communicating with people? How good are you in managing your team, right? In delegating work, as well as, being a team player, those kind of
Hmm.
things.
Yeah. Yeah. I love that you touched on that. It's like as engineers, we're trained to think through the technical cycle, and it usually stops at is the data accurate or some assessment of the results, right?
Yeah,
But
yeah,
it doesn't quite jump the fence to will this drive value for the business? And
exactly.
that's exactly where I see a lot of improvements that could be made throughout the technical life cycle because we focus on things sometimes that don't drive value for the business or
Yes.
that don't drive value for the client, the customer, and it's not natural. Like you said, it's not a natural thing unless you've been in that role and you pick it up and see
Yeah,
this
you've
is
been.
what they
Yeah,
actually care about.
exactly. Yeah.
Yeah. Yep.
So I think as engineers, we could write a report any given day, right? Like if we were asked to write, just like we wrote our thesis. But if the same thing, if we had to, present it as 4 bullet points, for example, uh, 10 years ago, I'd have difficulty doing that.
Yeah.
But I believe that's also comes with, you know, being in the industry, and
Hmm.
it comes with experience, and nothing bad about not being able to do that right out of college.
Yeah. Yeah, I really love how you talked about looking back now, a little bit shocked, overwhelmed, surprised that you took that role, but grateful you did, right? Like
Yeah,
looking back at the context. And I think that's true so many times, right? When you really stretch, that's when the growth happens, right? It's
definitely.
not when we're staying comfortable. So what role I see this theme here, right? You had an opportunity with someone you knew in your network that opened up your first experience with CFD, and then
Yes.
what role could you say about mentors in your CFD career and how that has helped you grow and help you succeed in those opportunities, right? I'm sure you weren't left on your own to do it. There was
No, no,
plenty of
no.
people helping, or at least a few
Yeah.
people really invested in your success.
So I think definitely my major professor who's had a very big role in the way that I started thinking about CFD, and from there on, I developed my own independent train of thought. I started questioning a lot of
Mm,
times, right? And
mm-hmm,
I've also learned a lot from my coworkers. So I had the good fortune of working with people who, like me, were trained in CFD and who, unlike me, had actually worked at other organizations, larger organizations. So they
mm,
brought back with them the more diverse experience and
mm-hmm,
more diverse experience in the area of simulation. And that's true here at SimScale as well. I get to work with such a diverse team,
yeah,
all of whom are subject matter experts in their particular line. And we bring all of it together to create this product, and we share this vision of enabling every simulation for everyone. So every day you learn something, right?
mm-hmm,
So yes, there have been a couple of people who stand out as mentors, right? Like, and those have been mostly teachers, right? Like uh, people who hold your hand in the beginning.
mm-hmm,
But I think along the journey, it's been about learning from every day, all of your coworkers, all of your you know like you. I got in touch with you because you are very knowledgeable about CFD. You are an established figure in multi-phase simulations, in the civil engineering related CFD simulations. And the first time, if I remember correctly, that I talked to you was to learn more about multi-phase
mm-hmm,
because I hadn't done that
yeah.
before. So that's how it is, right? Like you learn as from wherever you can.
Yeah, I definitely don't think I match what you described, but thank you. Yeah, it definitely is though. As long as you're open-minded and learning, willing to learn from others,
Yeah,
there's so much that you can learn from people. So let's talk a little bit more about SimScale and about your role now, right? It's more breadth. And we were talking
yeah,
about this before
yeah.
the show, the type of problems you're exposed to in your role. So
Yes,
maybe talk a
yes.
little bit about that and what it's like and what you've learned since you've been at SimScale.
So at SimScale, as I told you before, I'm the product manager for
Mm-hmm.
this vertical that's focusing on the rotating machinery applications. So definitely what I've learned about CFD applies here. And this here is the difference between academia, I would say, or an R&D focused firm, and a commercial firm that is focused on diversifying simulation, on making simulation accessible, addressable for many different kinds of problems for many different companies. And it's very customer focused as well,
Mm-hmm.
right? Like everything we do is driven by, are we able to solve a problem that somebody has come to us with, right? And
Yeah.
that could be, for me as a product manager, that could be anything from a turbomachinery simulation to UAV uh, simulation, or a wind turbine, for example, or a valve simulation. And of course, I haven't done all of it,
Yeah.
but my basic CFD training is definitely helpful because I understand the physics there, right? So
Mm-hmm.
I can give my viewpoint and I can have an intelligent conversation to understand exactly what the objective of solving that particular problem is. And that's what I take back as feedback for my team, for my engineering team. And we develop solutions, we develop, capabilities and features in the software to try and address the same problem for a wider audience.
Mm-hmm.
So that's my current role as a product manager at SimScale.
Yeah. I'd love to get your thoughts on this. So there's a lot of discussion that I see on different forums, CFD Online, LinkedIn, how to learn CFD, and see lots of people being willing to share their advice. And one of the things I think you touched on here is in the past, you could talk about CFD as just CFD because there wasn't the democratization of hardware or software.
Yes.
And
Yes.
so when you talked about CFD, it was a much smaller circle and the rules were more limited. But now you talk about having a customer focused product where, and correct me if I'm wrong, you're thinking a lot of the time, and how can a design engineer use this tool correctly who might not even need any training or background really on what's going on under the hood, right? We're going to button this up so tight that as long as they use it correctly, it will give them good results. And that's a very different way of thinking. And it's still CFD, right?
It's still CFD, exactly. Still CFD. And that's where the innovation on the software side comes in, right? We are putting our brains as people trained in CFD, whether it is a product manager like me or my fellow technical program manager who sits on the engineering team. We are putting a CFD training to build a product that is, first of all, available to all these different teams, right? Like, because there is, as you said, democratization of software, democratization of hardware. We are no longer, especially with tools like SimScale, which are completely cloud native, we are no longer limited by having that hardware infrastructure in place or connecting to a VPN, for example, right? Because that's what I remember doing traditionally or all throughout my training, right? And that's where the innovation on the software side comes in, is to simplify things and without losing the essence of numerical modeling, without losing on accuracy, for example, or the kind of methods that you're using under the hood, but package it in a way that it is usable and applicable for solving problems across, across teams, and whether it's a designer who's probably more comfortable staying in their CAD environment, or it's already a trained CFD person like me on the other side who is going to ask me questions, of course, who's going to, turn it around, turn the tool around, but yet should be convinced at the end of it that, you get the solution that you need.
Yeah. And that, I'm so glad you brought it to that point, that it's all about delivering the solution that they need in the best way possible for them, right? When you look at CFD for industry, and whether that's done with a highly skilled engineer or whatever method it is, who's trained in the methods and can really look at it. Yeah, it's great. That's interesting. I just finished, I'm sure this is probably old news to a lot of the external aero people, but the summary paper of deploying CFD at Boeing over 30 years. And I was just so blown away that that's exactly how Boeing approached it, right? By 2005 or 2003, whenever they'd written the article, 90% of the CFD runs were completed by design engineers outside of the CFD group. Right. And that was just so striking to me that that's how they really unlocked the value, was getting good, reliable results. Yes. Yep. Yeah. So last question here. What do you think? This has really come out all throughout our discussion too, but what else do you think is helpful, or a few closing thoughts on someone who's wanting to do CFD for industry, right? What things do you think are important if you're to summarize someone who's wanting to really do CFD for industry and do it well?
I think if you want to go into a developer sort of a role, I would really recommend going for higher studies after your undergraduate. And I would also really recommend, because a lot of times I see fresh graduates that reach out to me on LinkedIn as well, asking for opportunities, or, just kind of growing their network. And one thing that stands out on resumes good is having, project work that is either in some company or, using some commercial tool. So even if you don't have the incentive or the structure within your school or university to do those kind of projects, get out yourself. Nowadays, there are so many resources, right? You can sign up for a Udemy course. Coursera has a few things on SimScale, for example, has a
Hmm.
course on Coursera. And there are also so many avenues from where you can get your hands on D codes. Like there are a lot of open source codes that you can play
Hmm.
around with. There are freemium models like the SimScale community plan where you can just get on and start exploring. And
Yeah.
all tools almost have an academic program also. So get yourself acquainted with this. And what I also feel is we in the industry should have some sort of a give back kind of initiative. I don't know how I would structure that, but there are so many things happening in the industry, like Industry 4.0, the role of generative AI, for example, in CFD, which we ourselves are trying to understand, right?
Hmm.
So by the time this current generation comes into taking up jobs, they are going to be in the thick of these things, but do they
Yeah.
know what generative AI is? Do they know what role it has in CFD? Do they know, apart from the traditional finite volume and RANs or LES, do they know what LBM is? Do they know what smoothed particle hydrodynamics are, for
Yeah.
example?
Hmm.
So I think via interaction with maybe your alma mater, or changes to the curriculum, this is how a more up to date CFD knowledge can be incorporated at the student level,
Yeah.
and equip them to actually take on industry jobs where all of these things are going to be hot topics.
Yeah. Yeah. No, that's great insight. Project work and really staying abreast of the changes because it's changing quick.
Yeah, it is, right?
Yeah. Yeah. Well, thank you so much, Kenshin, for joining today. And I'm really grateful for this chance we had to talk together and really appreciate you coming on the show. Thank you.
Thank you so much, Kate. As I said before, it was lovely being here, and thank you for giving me this opportunity. And yeah, I hope it was a good discussion.
Absolutely. Thank you.
Thank you. Have a good day.
Thank you for listening. Really, thank you. What happens next is the most important part of the episode. Pick one thing that you can do in the next day to apply what you learned. Then do that one thing. See you on the next episode.